Chapter 4, Probability. Section 4.1, Empirical Probability. So in the first three chapters, we focused on what is known as descriptive statistics, where we learned how to just organize, summarize, and state the facts about the collected data. But our goal in this class is to be able to do inferential statistics, where we need to be able to take what we've seen in the collected sample data and then using probabilities, we will be able to make educated guesses about the population. So the next few chapters are all about probabilities and probability distributions. And for a while it's going to seem like we've left statistics, but these probabilities and their distributions are needed to be able to do the second half of the course, which deals with inferential stats. So first of all, a probability is a number between 0 and 1 that measures, and we should have put in here inclusive, meaning it can include those endpoints. A probability could be 0 or 1. So a number between 0 and 1 inclusive that measures how likely something is to happen. So one story about how probability theory was developed is that a gambler wanted to know when to bet more and when to bet less. So he talked to a couple of friends of his that happened to be mathematicians, and so they computed all these probabilities for lots of different gambling types of games that existed at the time. But since then, mathematicians have worked this in to develop this thing called probability theory that basically is used in any decision-making process in lots of different areas out there. So understanding probabilities is important. So some examples of just mundane questions is like, on the news today, we may have heard that there was like a 20% chance of rain. So maybe that influences whether you bring an umbrella as you're walking around campus or not, or the temperatures, whether you wear a heavy coat or not. But more important questions that probability can help are chances that your car that you're buying will need more maintenance. So again, with the internet, it's really easy to look up tons of information on different makes and models these days before we buy cars. Your chances of passing a class, your chances of winning the lottery, your chances of being in a car accident, and the chances that the U.S. will be attacked by terrorists. So many people do not have a very good understanding of probabilities, so they worry about being attacked by a terrorist, but not about being in a car accident. The probability of being in a terrorist attack is much smaller than the probability of being in a car accident, thus it actually would be more sense to worry about driving. Also, the chance that you win the lottery is very, very small, yet many people will spend the money on lottery tickets, because although the chance that you win is small, the amount that you would win is rather large. Yet, if instead they save the money they spent on the lottery, they would have more money. In general, events that have a low probability, under 5%, that's going to become important later, are unlikely to occur. Whereas if an event has a high probability of happening, like over 80%, then there's a good chance that the event will happen. Okay, so this chapter will present some of the theory that you need to help make a determination of whether an event is likely to happen or not, because this is going to influence our decision making when we start looking at doing more things with inferential statistics. So first we need some definitions as we start looking at probabilities. And the first of those is an experiment, which we all carry in our head different visions of what that might be. But an experiment is, in a statistical sense, is just any activity that has specific results that can occur, but it has to be unknown which results will occur before we actually perform the experiment. And then outcomes are just the results of that experiment. And then as we start looking at problems and trying to answer questions, we're going to be interested in computing the probability of certain events. So an event is just a set of certain outcomes of an experiment that you want to have happen. And we'll learn how to identify that as we read problems here in a minute. And then the sample space is just a collection of all possible outcomes of the experiment. And it's usually denoted with an uppercase S, and then we use set symbols, and in here we list the outcomes. All the possible outcomes. And then the event space is the set of outcomes that make up an event. And the symbol for this is usually a capital letter. So we might have some event space. Again, we use this set notation and list the things in here that we're interested in occurring. So we have a sample space that lists all the possible outcomes that can happen for a particular experiment, and then the event space that just lists the particular outcomes that we're actually interested in, whether or not they've happened.